Student, today I discuss about the single phase transformer. So first, what is transformer? A transformer is a device that transfer electric energy from one electric circuit to another electric circuit through the medium of magnetic field without a change of frequency. So, first is the definition of a transformer. A transformer is a device that transfer electrical energy from one electrical circuit to another circuit through the medium of magnetic field without change of frequency. Now, what is primary winding? The electric circuit which receives energy from the supply main is called primary winding. The electric circuit which receive energy from the source, that is the primary winding. Now, what is secondary winding? The other circuit which delivers electric energy to the load is called the secondary winding. So transformer have two winding, one is primary winding, another is the secondary winding. The circuit which receives the energy from the supply mains is the primary winding, and the circuit which delivers the electrical energy to the load is the secondary winding. Now, what is step up and step down? If the secondary winding have more turns than the primary winding, then the secondary winding voltage more than the primary, and that time transformer is called step up transformer. Okay, if the secondary winding have more turns, so that the voltage is more, now the system is called the step up. If the secondary winding have less number of turns, that time the secondary winding voltage is less than the primary winding voltage, so the transformer called the step down transformer. So basically transformer are step up and step down. If the secondary winding have more turns, that means its voltage at now is more than the primary winding, so that the system is step up. Again, if the secondary winding is less number of turn than the primary, so that the voltage of secondary less than the primary, that means it is the step down transformer. Now, as per the construction, transformer are two type. One is cord type and another is cell type. So basically, as per the construction, transformer are two type. One is cord type and another is cell type. Now, the cord type transformer achieved cord type transformer achieved by placing half of LV winding over one leg and half on second leg. Okay. For high voltage winding, half over one leg and other half on second leg. Remember that in case of cord type transformer, low voltage and high voltage winding, one half on one leg and other half on the second leg. Now, the low voltage winding always placed near to the core. So always remember that low voltage winding always near to the core, that means it is adjacent to the core. Why? Minimize the insulation cost. Okay, so minimize the insulation cost. Low voltage winding always placed near to the core. Okay, and in cell type, low voltage and high voltage winding are sandwiched in the central limb. Okay, low voltage and high voltage winding over the central limb, and it is sandwich. That means low voltage, high voltage, low voltage, high voltage. Okay, so these are the figure of cord type and cell type single phase transformer. Here as we say that the low voltage winding, this is the low voltage winding, is near to the core or adjacent to the core. This is the low voltage winding, this is also low voltage winding. These are the near to the core to minimize the insulation cost. Okay, and high voltage winding placing outer side. This is high voltage, this one also high voltage, this is high voltage, and this is the high voltage. Now in case of cell type transformer, winding are wound over the central limbs. Okay, and low voltage and high voltage, low voltage and high voltage, again low voltage, that means sandwiching structure or interleaf structure. Look at the picture of cell type transformer, that is top and bottom LV coils are the half of the size of the other LV coils. Again we say top and bottom of LV coil are the half of the other LV coils. Okay, remember that top and bottom LV coils are the half size of the other LV coils. Why? Because in LV winding current is more. LV winding, low voltage winding, in LV winding current is more. Okay, we know that the large current flow smoothly when coil diameter is large. Okay, large current flow smoothly when coil diameter large. Okay, that is to minimize the current in adjacent core, the diameter of LV coil should be half so that the current is reduced, and this is also reduce the insulation cost. Okay, so that is so very simple. In LV winding more amount of current is flow. To minimize the current in the adjacent segment, that is near to the core, we have to reduce the coil diameter half of the other LV so that the insulation cost also reduce.